Welcome, everyone. We'd really love to see you here. We're going to get started with the webinar. We're at 1 minute after the half an hour when our slated start time. So we're going to get started with the group we have. We want to welcome you today to the Metropole Project webinar, where we're going to talk about setting a new standard for community spaces, building restoration, and whole building efficiency. Today, we're going to do some initial introductions. We're going to talk about BetterBricks and setting the stage for this building, thinking about technologies and also resources for you as you might be thinking about projects like this. We're going to talk about the owner's perspective, the architect's perspective, and the engineer's perspective of the building design and implementation. And then we're going to have a panel discussion and moderated Q&A at the end. From a logistical standpoint, please type your questions in the chat, and we may be able to get to them during the talk, or we'll bring them forward at the end during the Q&A. AIA CEUs are available for today's webinar. There's a link here, but don't worry, we're going to drop it in the chat so it's easier to follow. It will take you to a Google form where you can put your name in, your AIA number, and we will submit those for one health safety welfare CEU for today's webinar. If you need a certificate of completion for your professional organization, we can also do that as well. So there's the link in the chat. Kaylin is helping me with some logistics today, so you'll see some things pop in the chat that are helpful links for our resources today. Here are on the screen are the learning objectives for today. I'll let you read those, and I'm not going to read through them myself. I'm really pleased to introduce our panel today. We have 4 wonderful speakers and myself. I'll be moderating today's discussion and keeping us moving along. I'm Heather Burpee, and I'm research professor at the University of Washington Integrated Design Lab. And I got to see the registration list for today. Welcome, friends, and welcome new friends. It's great to see a lot of friendly faces on the call today. We also have Dave Hammond with NIA, Kendra Walker with the Satterberg Foundation, Matt Alfs with Building Work, and Jonathan Heller with Ecotope. And I'm going to let each of them do a deeper introduction of themselves as we get to their sections. So with that, I'd like to hand it over to Dave to talk about NIA and BetterBricks programs.
Great, thanks, Heather. Yeah, and as Heather mentioned, my name is Dave Hammond. I'm the Senior Program Manager of the High Performance HVAC program here at NIA. And I'm going to spend just a few minutes here talking about who NIA is for those who are not familiar. So NIA, or the Northwest Energy Efficiency Alliance, is an alliance of more than 140 utilities and energy efficiency organizations that works on behalf of more than 13 million energy consumers across the Northwest. We are a nonprofit organization that works to accelerate the adoption of energy efficient products, services, and practices through a process known as market transformation. BetterBricks is a commercial resource delivered by NIA to help the Northwest building professionals gain a competitive edge in the market through the adoption of energy efficient products and practices. So internally, we're branded as NIA, but most likely you'll be experiencing NIA content through that BetterBricks alternative, I guess you would say, naming convention. So want to call out that there are some resources and tools available on the BetterBricks website that you might find helpful. So BetterBricks does provide tools and resources to help commercial building designers, builders, managers, and operators incorporate proven products and practices that improve the efficiency, resiliency, health, and overall performance of commercial buildings. You can explore a wide variety of content that we're continually updating, which includes case studies, technical guides, live and on-demand webinars, white papers, and more at betterbricks.com, on LinkedIn or YouTube, or you can sign up for our newsletter at betterbricks.com/newsletter. So pretty straightforward. And then before we head into the Metropole project specifically, I did want to call out one of the design elements that's incorporated in the Metropole project is the very high efficiency DOAS system approach. And that is directly tied to the program that I manage at NIA. And I just wanted to explain a little bit more about the elements that are included in the system design. And I'd like to ask if anybody has any additional interest in this technology or the system configuration, please don't hesitate to reach out. We can find if there are ways to bring more information to your project or to the audience that you work with, or to just provide more insights into how this could potentially become a part of your design that you might be working on. So just to call it out at a high level, the key elements of what very high efficiency DOAS includes, first and foremost, it's the fully decoupled ventilation from the heating and cooling system. So you can see on this diagram on the left, you have your ERV or HRV, and on the right, this one tends to lean more towards your VRF or variable refrigerant flow system, working in separate distribution. The second component is that ERV HRV or energy slash heat recovery ventilator that is operating at a greater than or equal to 82% sensible effectiveness. The third component is making sure that the heating and cooling system is a high performing electric heat pump system. And the fourth component is right sizing, making sure that that heating and cooling system is sized appropriately for the space and fully takes into account the benefits you get from the ERV HRV, making sure that that ventilation load is reduced, so you're not oversizing and spending energy unnecessarily. And then from the benefits of this system approach, pairing the highest performance HVAC equipment with those key design principles supports a variety of benefits, including indoor air quality and enhanced thermal comfort, and then bringing down energy usage in commercial buildings through a combination of analysis and case studies that have been completed through NIA. We have found that you can save up to 69% on the HVAC energy savings and 48% at the whole building level. Additional benefits, when you look to the owner side, it improves tenant retention. There are studies that showed the benefits of bringing this type of system approach into a building, how that can improve your bottom line, increasing your building value and sales potential, marketability, achieving green building certifications, those types of things. This can really play well into that space. Reducing system and maintenance cost, since you're downsizing the heating and cooling equipment, you're reducing maintenance costs and lifetime costs of the system, and then helping to achieve sustainability goals. So by providing an all-electric HVAC system for owners or occupants who value sustainability and or are looking to meet mandates. I'll throw in another element in here is achieving, especially for existing buildings that are going through major renovations, achieving higher performance as it relates to building performance standards or energy usage intensity. These types of improvements can really be a great option for those types of buildings. Moving over to the tenant side, from the thermal comfort angle, it really just does allow to have better control, better response to the individual's comfort settings. So by having those distinct thermal zones and individualized control for each unique workspace, it really does improve that perception of thermal comfort, which then leads to improved tenant satisfaction. This also plays over into the indoor air quality, right? They all work together to create a, a better indoor experience for the tenants. And then finally, back to one of the components that is offered through NIA's BetterBricks website, we have a dedicated section for very high efficiency DOAS. You can go to this webpage and look through all the resources that are available. We have a number of case studies. We have some great white papers, some technical resources available. There's literature that can be taken to events if you're trying to represent different options to a broader audience. Really just trying to put information into the hands of the market actors who are most likely going to continue this messaging through to the design stage. And that is it from me for today. So I'll send it back to you, Heather.
Perfect. Thank you, Dave. Thanks for setting the stage with some of the NIA BetterBricks programs that the audience might be able to access and utilize in their projects. Now we're going to transition to talking about the Metropole Project, and we're going to start with Kendra Walker, who is with the Satterberg Foundation, and she's going to be talking about the owner's perspective on on acquiring and designing this building. Kendra.
Thank you, Heather, and hello, everyone. My name is Kendra Walker. I am the Metropole Community Steward. I focus on community relations as well as facilities management for the Metropole. And first, I wanted to give you a little bit more insight into who the Satterberg Foundation is as the owner of the Metropole. The Satterberg Foundation is a family foundation based in Seattle, Washington, that gives grant dollars to nonprofit organizations that are located in Washington State, California, and Arizona. The Satterberg Foundation is the vision of Ginny Satterberg, and the original board came together in 1990 with an initial mission to improve the quality and life in the Pacific Northwest community through focused, considered grant making. Over the years, our mission has changed, and the current mission is that the Satterberg Foundation strengthens our communities by promoting a just society and a sustainable environment. Doing this work deepens the interconnection of our family. So something that's a little bit different about this organization is that we are a family foundation, which means that every person that serves on the foundation board is a family member. And in terms of just society and sustainable environment, when we speak of just society, a lot of our nonprofit grantees focus on work in the area of social justice and racial equity. And in terms of sustainable environment, many of those organizations focus on sustainability projects and initiatives in a wide range of areas. Our grant strategy is called trust-based philanthropy. We also consider it relational grant making, and it's an approach to grant making that prioritizes knowledge sharing and open communication. And we believe this way of working leads to stronger and more impactful partnerships. We've been very intentional with using trust-based philanthropy, and through that, we do it through multi-year general operating funding, valuing our partners' lived experiences and expertise, and authentic relationships in lieu of reporting. Many organizations that receive philanthropy dollars often have to go through a long and extensive reporting process, so that we find that this takes away from the really important work in the community. Therefore, we do more relational meetings with those partners so that they can actually do the important work in the community. Next slide. And to give you a little bit more insight into the Metropole purpose and vision, prior to the purchase, there was a strong desire from the board to invest in a meaningful and impactful way in downtown Seattle. We were also hearing at that time from many of our grantee partners that they were being pushed out of Seattle due to the rising cost of rent. So the building was purchased in 2019, and we know that 2018, 2019 was really the highest point of rent in downtown Seattle. Many of those organizations that were hit hardest were led by BIPOC individuals, as well as those organizations that serve communities of color. Therefore, the vision of the purchase was to provide below market rent office space, community amenities, and camaraderie in a beautiful setting that adheres to the highest environmental and sustainability standards. Pre-pandemic, things were quite different than post-pandemic. Pre-pandemic, it was quite popular to have co-working space and different needs. So after the pandemic, we really knew that we needed to take a very intentional approach to how we designed the building and also the program mix of the building. So in terms of redevelopment and community engagement, we had a very intentional, thorough, and continuous process for community engagement, and that has guided many of the decisions of the layout and design of the Metropole. We talked to hundreds of community advocates, nonprofit organizations, and residents in Pioneer Square, as well as Seattle. And we did that through focus groups in-person interviews, and virtual meetings. From those meetings, we designed and developed the program mix and design of the building. What we learned from those meetings was that there was a strong need for meeting space and conference rooms, shared amenities, individual tenant offices, childcare, community kitchen, and art space. In addition, there was also a strong need for inclusivity and affordable rent. Many of those folks wanted below market rent. They wanted a building that was fully ADA compliant and also incorporated all gendered restrooms. There is a strong need towards traditional leased office space where we knew pre-pandemic there was a drive towards co-working, but now many of these folks were saying they wanted to know what their rent was going to be and they needed to be able to build out a sustainable budget by knowing exactly how much they would be paying year over year. And then, of course, people wanted a sustainable environmental design. Clean energy was also a big part of that. In addition, there is also a desire for us to have intentional building culture within the building, as well as strong tenant feedback throughout the design and also throughout their tenure at the building. And that concludes the process of a community engagement.
Perfect. Thank you, Kendra. Thank you for setting the stage about the Satterberg's mission and the vision for this project. With that, I'm going to hand it over to Matt Alfs, who's going to talk about the architect's perspective of the Metropole Project. Take it away, Matt. And you'll want to unmute yourself to get started.
There we go. Thank you. Thanks, Kendra. And thank you, Heather. My name is Matt Alfs. I'm a founding partner of Building Work. We're an architecture firm in Seattle, Washington. And we focus really on two project types, projects that are community and civic focused and adaptive reuse of existing buildings. And so the Metropole building really brings our two areas of focus together in one project. And it was really an incredible honor to lead the design team for this project, which I think sets a new precedent for what adaptive reuse can achieve in terms of climate responsive design and community centered design. Next slide, please. So the opportunity, this is a photo of the Metropole building before we started work on the project. It's located at this incredible spot right at the edge between the Pioneer Square National Historic District and downtown Seattle, and just to the west of the Chinatown International District. So it's beautifully located. It's near King Street Station, the revitalized waterfront, and it's across the street from the Smith Tower, if any of you know that landmark building. But the Metropole building was in a state of severe disrepair. It was essentially abandoned and unoccupied for about 17 years. It had suffered damage from multiple earthquakes, fire, weather, and general neglect. So it was really kind of a ruin, but really what we're able to do working with the Satterberg Foundation is bring the building back to life and transforming it for a entirely new purpose. Next slide. Because of the complexity of this project, both in terms of the mixed use program, which we're not going to really talk about today, but a really important mix of community focused uses, the condition of the building, which required a tremendous amount of structural repairs and upgrades, and then the sustainability goals. We really took an integrated design approach where the entire design team was working together from the beginning, answering these questions and thinking through these challenges in order to innovate and address the needs, not only of, as I mentioned, the functional needs of the building and the program, but we had restrictive historic preservation guidelines. We had mandatory building code upgrades that we were trying to balance along with innovation. This is just a quick diagram that shows, we reconstructed in that green color 2 upper floors that had collapsed in the 1949 earthquake. Full seismic retrofit, as I mentioned, facade restoration, new stairs and elevators. In red there, we tried to create a really attractive feature stair that it's a fire rated stair, but it's enclosed in a glass wall, really hopefully to invite occupants to use the stair both for their health and for lower energy performance of the building. Next slide. So real briefly, I'm going to touch about, from the architect's perspective, the environmentally responsive or sustainable design strategies that we employed. John Heller from Ecotope will go into more technical detail. The project, I'm happy to say, not only was the project designed to meet LEED certification. We actually received LEED Platinum certification last week. I think that's an accomplishment in a historic building. There's not that many LEED Platinum buildings in the world, and there's not that many in historic buildings. As John's going to discuss, the design has an extremely low energy use index, EUI, of 18, which makes the Metropole one of the lowest energy use buildings in Seattle, period. We have a highly innovative HVAC system using natural ventilation, air source radiant heating, and air source passive chill beam cooling. We're taking advantage of the historic large windows for natural ventilation and occupant control. We have a very, very efficient thermal envelope. We use triple glazed wood windows throughout, and at the street level, a triple glazed wood curtain wall, which is a really innovative system. We eliminated fossil fuels and red list materials. We also, in this photograph, you can see really minimal new finishes and new materials. We're really thinking about carbon impact. And so we celebrated both the historic materials, brick, timber, and cast iron, but also exposing the engineering. Overhead, you see passive chill beams, hydronic piping, and really letting that be part of the story of being inside the building. We have on-site power generation with a solar panel array and battery storage, on-site bicycle storage and showers to support non-motorized transport, and vegetative and reflective roofs. Next slide, please. I'll show you some examples on the next few slides. This is the completed project with the restored sandstone facade and brick facade. Down at the street level, that purple colored window system, that's a wood curtain wall, again with triple glazing. And so the building is now sort of reestablished as a civic presence in downtown Seattle. Next slide. Just a detail of where we had to bring together restored facades and new materials. On the upper left in the gray brick, that's the facade of the reconstructed floors that had collapsed in 1949. Next slide. Downstairs, this is an interior shot of the conference and event area. And you can see our approach to the materials, a really honest and straightforward approach. Cast iron, steel, and timber is exposed. It's infilled with concrete where that was required for structural reasons, and all the new building systems are carefully organized and exposed overhead without additional unnecessary materials and finishes. Next slide. This is a view of the main lobby as you come in off 2nd Avenue. To the left there is the entry vestibule. And so this is an orienting space. Overhead, you see the passive chill beams. They're those white linear elements. There's 3 of them in view here, and I think those are interesting. It's not that many buildings that use this really, really energy efficient cooling technology. In the back on the bottom, you see the hydronic radiators that are providing heating. And again, the exposed ceilings and coordinated infrastructure. Next slide. Just an aerial view looking down. We had really limited area. We had no site. The building is the exact same size as the property. And so it was challenging to meet LEED Platinum. We used every square inch we could of the roof, and this shows some of the outdoor amenity areas, the photovoltaic arrays, the air source heat exchanger farm on the roof, and how we sort of shoehorned all those elements together. And next slide. I believe this is my last slide, just an overall view of the project, another drone shot, giving you a sense of the new construction elements on the roof and the restored building facade. So I'm going to turn this over to John Heller at Ecotope, our friend and collaborator, and looking forward to answering any questions that you all have when we get to the Q&A. Thank you.
Perfect. Thank you, Matt. And take it away, John.
Great. Thanks. I'm John Heller. I'm president of Ecotope. I'm a mechanical engineer. I was involved in some of the early conceptualization of the very high efficiency dedicated outdoor air system program that Dave introduced earlier. And super huge honor to be involved in this project because it's such a cool project, both the mission of the building itself and the approach to energy efficiency and sustainability. Go ahead to the next slide. So I'm going to be presenting the energy and mechanical goals that we were shooting for from laid out by the Satterberg Foundation, how we approached integrating super efficient HVAC into a historic building, and then more of the what and why of the HVAC system selection, a little bit about grid integration of the building and some of the lessons learned. And I've got Greg Wenzel is on the chat. He was the engineer of record, so any detailed questions that you want to ask, he can provide some answers in the chat. But I've only got 15 minutes, so it's going to be a little bit high level. Next slide. So Ecotope's design approach for responding to the climate crisis focuses on 3 areas. Design for off is our recognition of the fact that the most energy efficient HVAC system possible is the one that you can turn off. And design for off really mirrors the VHE HVAC system approach that Dave introduced at the beginning, focusing on reducing the loads as much as possible so that we can have smaller, simpler systems that we can cycle off when they're not needed. The electrified buildings component of our approach is really to prioritize efficient heat pump systems in lieu of burning fossil fuels whenever possible in buildings. And then when matters relates to creating flexible loads in the buildings because to integrate with the developing grid, because as the grid relies more and more on solar and wind, when we use energy starts to matter as much as how much we use. Go ahead to the next slide. So the goals for this building was to really maintain the historic character of the building, prioritize occupant health and comfort, use zero fossil fuels, achieve that LEED Platinum and comply with the Seattle 2030 district targets, and focus on an extremely efficient HVAC system. So we're modeling the building as delivering an EUI of 18. Next slide. Yeah. So the first focus was on this shell of a building was bringing the heating load down as much as possible while maintaining the historic character of the masonry walls on the inside and out. And so in order to have a well-insulated envelope while still maintaining a lot of the exposed masonry, we focused on getting the best windows available, which were triple pane wood windows delivering a U value of less than 0.2. And that allowed us then to just insulate select areas of the wall, which were not as impactful to the indoor character. Another component of reducing the load was focusing on high efficiency heat recovery to bring the ventilation load down as low as possible. And by bringing the load of the building down, we can minimize the size of the HVAC equipment, which was pretty important in this type of historic building because it means smaller ducts, smaller pipes, lighter weight mechanical equipment on the roof, makes for easier integration with an old building. Next slide. So this led us, Matt shared this drone photo already, but it shows you the extent of the heat pump system on the roof. The HVAC selection was really geared around that very high efficiency dedicated outdoor air system approach that Dave described, using air to water heat pumps as an all electric high efficiency system, hydronic zonal distribution, heat pump water heating, solar as much as we can fit on the building, and an energy management system. And I'm going to talk about each one of those components in a little bit more detail. So the heart of the design is really these high efficiency heat recovery ventilators. They're the only pieces of equipment that need to run during most occupied hours of the building to provide fresh air and exhaust air. They're counterflow heat exchangers to provide a very high level of thermal effectiveness so that no tempering is required of the air. The air can be, the 100% outside air can be delivered directly to the occupied spaces. And since it's 100% outside air that's sized just for air quality, the ducts are as small as possible, which is important in a historic building like this. And then air quality monitoring and variable speed, high efficiency fans with zonal controls means that the fan energy is as small as possible as well. There's a passive active mode signaling to the occupants that signal them to utilize operable windows on the upper floors when the outdoor conditions are favorable. And it's really that separation of the ventilation from the heating and cooling that allows us to turn the heating and cooling systems off until there is a demand for heating or cooling in the individual zones. Next slide. So then the heating and cooling now is provided but with air-to-water heat pumps on the roof. Multiple small stages of heat pumps allows for staging and redundancy. There's 2 redundant heat pumps to allow for maintenance or heat pump failure and replacement. And it also keeps the structural loads down on the historic building. They're what we call a monoblock design, which means that there's no field connections of refrigerant. The whole heat pump refrigerant system is contained in a factory delivered unit, so it really reduces the chance of refrigerant leakage and minimizes the amount of refrigerant on the project. Has no refrigerant is inside the building. And the system also includes large thermal buffer tanks, which allow for better cycling of the heat pumps and will also allow for some demand response to turn the heat pumps off during peak demand periods. Next slide. There's 3 primary ways to deliver heating and cooling, to distribute heating and cooling in a building. There's ducts using air as to distribute the heating and cooling, which require pretty big ducts and a lot of fan energy. There's refrigerant piping, which is what you see with variable refrigerant flow systems, for example. Or there's hydronic distribution using water and water terminal units to distribute. And there's a lot of benefits of hydronic distribution. In this case, we're using a combination of the passive chilled beams that Matt showed, radiators, and in the higher occupancy zones, fan coils as well. But in most of the spaces, there's no fans being used to deliver the heating and cooling. This provides for the maximal energy efficiency. Pumps are way more efficient than fans or compressors to push heat around a building, 5 to 10 times less distribution energy. Resilience, the distribution system in the building is really agnostic to what's creating the hot or cold water. So the heat pumps can be changed out in the future on the roof without any impact to the internal distribution, which is not the case if you were using a VRF system, for example. The refrigerant piping is likely going to have to be changed if and when the heat pumps are changed outdoors. Hydronic is also a lot easier to reconfigure the building than if you've got a big ducted system and want to change that around. Leakage, you know when a hydronic system is leaking, it's pretty obvious and easy to repair. air distribution systems, typical 5 to 10% leakage in that. And leakage in refrigerant distribution systems can be catastrophic to health, environmental impact, and the performance of the system itself. Next slide. We're also using heat pumps for heating water for the commercial kitchen and showers in the building. Again, we're using multiple small stages with one redundant heat pump. It looks like there's 4 heat pumps in that picture, but one of those is for the elevator machine room. So there's three small heat pumps for the hot water system. And then large thermal storage tanks, again, which provide for long cycles of the heat pumps, which the heat pump equipment likes, and also allows for load shifting off of peak utility times with that thermal storage. Next slide. Matt showed the photo maximizing the area that we're using for solar panels. We've also, the building has set aside space for potential future battery storage. And the mechanical systems were set up to allow for a demand response to shut down some of the heat pumps during peak utility periods. One of the lead points was related to being able to shift 10% of the peak building demand in response to a demand response signal from the utility. The grid integration, demand response programs, time of use pricing is all just beginning to happen at Seattle City Light. These are all ways that Seattle City Light will begin to incentivize buildings to respond with load flexibility to lower peak demands. So we took all of that into consideration in the design of these systems to make it as flexible as possible as those programs begin to get rolled out in earnest by the local utility. Next slide. So just a little on the challenges and lessons learned from this. The photo shows a lot of equipment that had to be added to this 19th century building to bring it up to modern standards. Remember, this building was built before electrification. So even the lights were not there in the original building. Putting these systems into an existing historic building means there's a lot of unknowns. We had drawings, but the drawings are never going to be, there's always a lot of things that are learned in the field during construction that lead to redesign of the systems, moving things around. So one of the lessons learned for us, I don't know if Matt learned that, he probably already had learned this lesson from his other projects, but to consider some contingency in the design, because we're going to learn a lot of things in the process that we didn't know were there when we start out in terms of structure and actual locations of walls and so forth. Another lesson learned is I think that we're going to need to have a broader conversation in the city of Seattle about the balance between the value of preserving these old buildings and the demands of the escalating energy code. This building was submitted under the 2015 energy code. And even though we're achieving an extremely low level of energy use, we barely squeaked by the 2015 code. And so there's some, as I say, some conversation needs to happen about how do we balance these things because we want these projects to happen. We want low energy use, but we want these projects to happen. And they're not mutually exclusive. There were quite a few lessons around the integration of the air-to-water heat pumps. these are really emerging technologies still in the US. There are several on the market, but there are more coming on the market all the time with better controls, better staging, turn down ratios, new refrigerants. And so, they're pretty sensitive to flow and pressure requirements. So it was very important to us to have good support from the manufacturer representative. A shout out here to Johnson Barrow, who were very thoughtful and supportive in our coordination of that technology into this building. There were some other lessons learned about the air-to-water heat pump that you could ask. Greg could give you some more ideas about that in the chat, or if you show up to the tour, you can dig more into the details of that. And then just finally, I'll say that BetterBricks is supporting additional long-term monitoring of this building and a case study write-up. So we'll have actual performance data beginning to roll in soon, and over the next 6 months to a year, we'll be evaluating the actual performance of the building and producing a report about that. Back to you, Heather. How'd I do with time?
Amazing.
Good.
Thank you. Thank you to the four of you for those fantastic presentations and setting the stage for us about the Metropole project. I think I'm going to start the Q&A with my own question. A couple of things that I'd like to do for housekeeping first before I do is I'd like to ask Kaylin if she would repost a link to a Google Sheet that will allow you to sign up for AIA CEUs. In case you came on a little bit late, know that you can get CEUs for this presentation, both AIA or if you need a certificate of completion. So she'll drop that in. There it is, so you can go to that. I'd also like to encourage you to drop any questions you have into the chat, or raise your hand and we'll go around and try to answer your questions. As you're thinking about them and formulating them and getting excited to raise your hand, I'm going to ask the panel I think Matt said it in his presentation. This project really exemplifies what is possible in a historic preservation project. To achieve such a low EUI and LEED Platinum while also, following the historic preservation guidelines is a fantastic achievement. I think it's a project that many people on the call would love to be involved in and be able to work on in their own careers. And I'm curious, kind of stitching together what you did from Kendra's presentation about the initial ideas from the community about what they're looking for in terms of environmental design, to the realization of such an energy efficient building. I'm curious and I think I might put Matt on the spot to, if you talk about the movement from the high level goal of environmental sustainability and the process that happened to get to this level of implementation. What was the goal setting and the process like that the team went through?
That's a great question. And what I remember when we started the project, leaders of the Satterberg Foundation came to us and they said, as Kendra said, their mission is to advance environmental sustainability and a just society. And so those two goals were equal for us. We were given that charge to implement this community-focused program that's focused on communities of color and to make the building as sustainable as we can be. And the individual at Satterberg Foundation basically said, well, how sustainable? Go make it as sustainable as we possibly can. And they said, well, look at the Bullitt Center. Let's do that. Let's do the Bullitt Center. And we looked at it and we said, well, what can we do in terms of an existing building with no site, no ground around it? What sustainable strategies can we employ? And we had a series of workshops and charrettes with design team members, owner representatives, project representatives to explore different. We looked at Living Building Challenge. We looked, of course, at 2030 District. We looked at Salmon Safe. We looked at other sort of programs to gather what would make the most sense. And at the end of the day, we focused on LEED Platinum because it's a set of frameworks and requirements that people understand, our team members understand. And then we pulled other elements from other programs that were viable and possible in an existing building with no site. And those constraints are real. It's not just the amount of coordination just to achieve this in this existing building was really challenging. So yeah, I guess I would say it was a series of workshops and explorations where we went from the question, how sustainable can this building be, to what's possible, and then we presented options to the ownership team, and they basically said, let's go. So I really hand it to the client group, the Satterberg Foundation, for their vision and their willingness to trust that the design team would, that we'd be able to pull it off. And I think the full design team, we really had to pour our heart and soul into it. I mean, this was, I would say, the most complex project that I've ever worked on in 30 years.
Wow. That's great. John, did you want to add to that at all, or?
Makes me feel good that you said it's the most complex project you've worked on in 30 years. I'll echo what Matt said about the value of the client trusting the design team, because that's huge for us to be able to really utilize be innovative and not have anybody second guessing us, and willingness to use new technologies is huge. I would say, just to kind of make a plug for Dave's program, the VHE DOAS program, this building did lend itself exactly to the use of that. This is a historic building. You can't just run a bunch of ducts through.
Right.
It's really hard to do. And the desire for super low energy just kind of lends itself exactly to that kind of approach.
Yeah, and from my perspective, it's fantastic to have a built example that we can see with our own eyes now, and that has implemented that strategy, so that we can imagine how other existing buildings might be able to be retrofit in a more, I guess, efficient way. So seeing is believing, which is one of the reasons why we're doing this webinar today. I'd like to invite anyone in the audience to raise your hand or type a question in the chat. We've had a couple questions about specific technologies, and thank you, Greg, for jumping in there and answering those midway. I also want to say, while I'm still on a roll saying things, we put together a survey about the webinar today. Feel free we'd love to hear from you, and it's just a quick Google form, and Kaylin has dropped it in the chat. So please feel free to jump on that form. Let us know what you think. If you'd like more of this kind of content, if you would have liked to have dived deeper into anything, let us know. Okay. So here's a very specific question from the chat. And maybe I'll widen it a little bit. And, Kendra will speak to how long the building has been occupied. Not very long. You all moved in, when, 2 months ago? Is that right?
The end of May.
End of May. Oh, sorry.
2025. Yep.
More other things were happening more recently, so you have a little bit of experience. There's a question about this comes up a lot when we have a chilled beam and we worry about humidity. Has there been condensation on the chilled beams that we've seen so far? And maybe I'll ask John that as a specific question.
Not that I've heard. No.
Yeah.
No, the delivery temperature of the water is warm enough to avoid that.
Yeah, we
Yeah,
hope not, right?
This is Greg.
Oh, thank you, Greg.
I would just add to that. We're also monitoring the indoor conditions to basically reset the water temp as needed to anticipate any potential condensation.
Great. I have a question about kind of the integrated design process. And I know we've had conversations offline about this a little bit as we built up and planned for this session. But I'm curious from the perspective of we have this really deep energy goal, we have a historic structure, and what kind of process or tools were used, say, for example, energy modeling, to look at the facade and understand how much insulation was really needed and where? So you talked a little bit about the window and the wall insulation trade-offs. How did your team do that analysis?
Let me start, and John can jump in. I mean, just in general, integrated design, we had over 3-year design process, some of which was during the pandemic. And so it was challenging, but our approach is to move as much information amongst team members in any way that we can. And so that's in-person meetings, it's Zoom meetings, it's phone calls, it's emails. It's just a lot of knowledge sharing, idea sharing, and questioning that goes back and forth during design. And integrated design is kind of a term that we use like sustainability, but you got to be integrated, right? Like it's not really a thing. It's really just like what's required. Flexibility, open mind, and just a lot of information sharing. In terms of the brick, I mean, I will say as the architect, I really wanted as much exposed brick as we could get. And so that was an aesthetic condition. It was sort of honoring the materiality that's embedded in this building. Those bricks were laid 130 years ago. Same with the timber. The timber in that building was milled by Henry Yesler. Those are old growth, ancient trees that were cut down and to build that building. And we wanted to honor them. We wanted to keep them exposed. I didn't want to see the inside of this building covered in painted sheetrock. And so we actually challenged the Ecotope team to say, how much brick can we keep exposed? And we went back and forth, and energy modeling occurred by Ecotope. And then we ended up with a strategy where in back of house spaces, below grade spaces, we did fur and insulate. But in the main spaces, what I thought of the high value spaces, we just insulated from the windowsills down to the floor. And that's it. And then that's the zone where we have the hydronic radiators attached, and that insulation was required. And then I think one of the trade-offs to that was to use triple glazed wood windows but let's also keep in mind the walls are in some cases over 2 feet thick, masonry and stone. So we've got a lot of mass there.
Right.
But anyway, let me see what John wants to say about that process and those considerations.
Yeah, I would say that there was a lot of trade-offs to meet energy code, as I said before. And one of the challenges with the wood windows was that since they're custom windows, they do not have an NFRC rating, which is required by the energy code. And so we had to use a default number, which is pretty conservative for the performance of those windows. So the windows actually perform quite a bit better than the energy code model would suggest. But the systems were sized to take that into consideration, and it was important to get those windows were very important to the sizing of the mechanical system. To have it be small enough to fit on the roof and for the structure of the roof to support the heat pumps. If we hadn't used as efficient of windows as we did, that would have been much more challenging.
Let me add to that on those windows, because I mentioned wood curtain wall. That's why we used a wood curtain wall system. At the street level, we have really large openings. I think they're about 16 feet wide and almost 15 feet high. And we had to fill those openings with window wall. Well, we're not going to use aluminum storefront. That's not allowed in historic district. And even if we had used storefront, you would have to subdivide that with a structural beam, and then that becomes a whole extra layers of openings for thermal bridging, and it's a real challenge. And so we found a wood curtain wall product that's made in Canada. It's a hybrid system. It uses some hardware from Germany, and I don't think that system. I'm not aware that system has been used anywhere, certainly not around here before. So it was an innovation that we were able to find, and we were able to. I think it has an extremely low U value, less than 0.2, and fill those entire openings rather than have them broken up with structure that creates thermal bridging. And so and then the upper windows are an Anderson wood window with triple glazing that has a really good U value as well.
Great. Very briefly, I'm going to take a question from the chat, and we only have a couple minutes, so I want to make this one brief. But, and Kendra, I'm going to pose this to you as a starting point, at least. We understand that we can get a design on paper designed to meet a certain EUI, but how the building is actually operated plays into how it actually performs. So there's a question in the chat about, what kind of work was done to help educate or prepare the building occupants for residing in this building.
Thanks, Heather, and thanks to the person in the chat that asked that question. We actually, so before the tenants moved in, we actually worked with each individual tenant group to design their own space. And so Satterberg Foundation actually paid for the design and all of the office space within each individual tenant space. And so some of they're all designed quite differently. So some of them just have, standing desks and chairs. Some of them have lounge spaces. Some of them have kind of, mock boardrooms or meeting rooms with like either an oval table or even sometimes a rectangular table. We have one organization that didn't want any desks, and they only wanted actually one individual desk, and then they only wanted that boardroom table in their office. And so we did actually work with each individual tenant to design their own space so that it fit their needs. And we also wanted to take the cost and the burden off of the tenants to be able to supply that for them. We also had some lead design requirements for some of the office furniture that we used. And so that also allowed us to have a little bit more control over that, to make sure that we were only using clean materials within the building space. And so that also there's white, all of the, white countertops and white desktops, so for the light reflectivity. And then there's also a training period, right? So once they moved in, we worked with each of the individual tenants to train them on the HVAC system. And I think in one of Matt's slides, he talked briefly about the windows that go up and down and the red and the green lights. And so we also worked with them and trained them on that.
Fantastic. Thank you, Kendra. With that, I love it. The questions get going right at the end. We didn't get a chance to answer all of them, but we need to say goodbye for now. We want to highlight that we are going to be doing a building tour of the Metropole Project. Some of you are registered for that. We are in a waiting list situation with that. But what I'd like to say is we may offer another tour date. So please don't be shy to join the wait list for this tour, because it'll help us understand what the interest is. So please sign up for that. And Kaylin just dropped the registration for that into the chat. So don't be shy. And I'm going to leave us on our pictures, and our emails are here. So please reach out if you have further questions about the things that we talked about today, or questions generally about the Metropole Project. We really appreciate you being here today. Thank you for your interest and for your attention, and we'll see you the next time. Thank you.
Thanks, everyone.
Thank you.
Come to the tour. Come see us at the tour.
Yeah.
All your questions will be answered at the tour.
And you can hear the crowd going wild in the background.
Thanks, everyone, for coming.
Thank you.